Hi everyone, I'm Akanksha Balani and I'm the AWS Alliance Head for APJ for Intel. I'm very excited to talk to you about how the power of compute and technology leadership on AWS EC2 and Intel can help power better price as well as boost best-in-class performance for you on AI. So let's get started. The flow of today's session will be me going over how AI as a technology is transforming every facet of our lives today, the history of how Intel and AWS have partnered on cloud computing across various deep tech workloads. I will also then talk about what AI-based platforms that are powered by Intel are available on AWS EC2 platforms today. It is also my pleasure to introduce hot off the press details on Habana Gaudi instances announced by Andy Jassy at reInvent last year. We will then close with showing you the path of how you can work with us in 2021 to build the fastest and the most cost-effective AI for your organization. There is a survey that shows that by the year 2023, there will be 50 billion devices and 500 billion sensors smartly connected to the internet. The connected world has created a deluge of data in the hands of every organization and individual. The need to analyze this data using the power of AI and ML for providing deeper and productive businesses and societal insights has never been stronger than today. What has come to surface is that to drive the fastest insights with AI, there are three needs that Intel's platform fulfill. Number one, performance. Number two, performance. And number three, performance. AI has transformed the way in which businesses today are driving the right analyses towards product, business, and societal excellence. All industries today, as the slide demonstrates, have deeply been impacted and evolved with the power of AI. The rapid rate of adoption in AI in each of these segments is dedicated or dictated by three factors. One, clear available use cases as defined below in each industry. Higher purchasing power of the segment, as well as the high rewards for making decisions quickly and more accurately. With these growing needs, we start to see a convergence of data insights with computing capabilities. AI needs extreme computing power to perform at the rate of its demand. Keeping this need for this critically performant computing power for AI, Intel has also been transforming into a more data-centric organization as well as a technology provider. Intel has today a plethora of hardware and software to make AI happen from data center to the cloud. I will touch on each layer of this slide from the bottom up. First, let's look at the hardware. Intel's comprehensive product portfolio spanning general-purpose compute to accelerated compute provides customers on the cloud a variety of compute capabilities that support the right optimizations to seamlessly build and deploy for your AI. It all starts on a foundation of the Intel Xeon scalable processors that are accelerated with Intel-optimized AI software. The built-in hardware features of Xeon, like the AVX512 instruction sets, the vector neural network instruction sets, and the deep learning boost capabilities are meant to accelerate AI at scale. In addition to Xeon, Intel also has the Habana Gaudi accelerators for heterogeneous AI. The next layer above the hardware is the libraries. The Intel distribution of Python, the Data Analytics Accelerator library, and the ML optimizations of the MKL libraries help AI developers and programmers with access to pre-optimized performance goodness while building their AI and ML models. The layer above the libraries we have done a lot of work on is at the frameworks level. For the data scientists building their AI/ML models, Intel has optimized the most popular open-source community frameworks for deep learning to deliver peak performance on CPUs, GPUs, and accelerators. The layer above is for the application developers, where we have a variety of tools as well as Intel's AI software suites, like the OpenVINO and the Deep Learning Developer Toolkits. These feature data scientists as well as developer productivity tools that compress the deep learning innovation cycles across various use cases like computer vision, NLP, IoT, etc. Since more than 14 years, Intel has been driving a strong engineer-to-engineer relationship with AWS. That is reflected in our shared customer obsession and constant technology iteration to keep in mind the needs of our customers and partners. Intel strives to deliver the most optimized and performant solutions built upon our custom silicon SKUs on AWS. Amazon Web Services and Intel have developed a variety of specialized instances, from high-performance computing to big data to AI and the Internet of Things, to meet the needs of organizations today and into the future. The Intel Platinum Xeon processor family are the foundation of the cloud computing services deployed by AWS. Amazon EC2 instances powered by Intel processors have the largest breadth, global reach, and the availability of compute instances across AWS geographies. Whether deploying hybrid cloud with AWS Outposts, or SAP HANA with high memory instances, or high-performance computing with C5N or Z1D instances, Intel's architecture is at the heart of Amazon EC2 instances. Our focus has always been on delivering cutting-edge technology plus value, which is delivering the highest performance at the lowest costs. AWS continues to accelerate the pace of innovation. In 11 years, by 2017, a single instance had grown to 70 instances, and just in the last 2 years, AWS has nearly quadrupled offerings with more than 250 plus instances today. If you look at the range of AWS instances that are powered by Intel's technology, we work together to design instances, be they compute or memory or storage optimized ones, to ensure demanding enterprise applications can run in an optimized and scalable manner in the cloud. The goal is one architecture for edge to cloud so that any optimizations we make in the cloud can also benefit at scale. Specifically for AI, this shows you a list of Intel instances that are available on AWS EC2 today that are commonly used for building most performant AI. The M5 and the C5 instances are suitable for all computer vision, ML, and DL inference workloads. The R5 instances are for memory-optimized workloads, which use 3D CNN or BERT large or T5 topologies with memory requirement more than 192 GB. The T3 instances are better suitable for ML applications and low compute DL inference applications. The C5N instances are suitable for distributed deep learning training due to high network performance required for internode communication. And the bare metal instances are preferred for large topologies as HVM-based instances, adding 10% performance overhead. Bottom line, there is a comprehensive portfolio of Intel Xeon-powered instances on AWS EC2 that can help you leverage and customize for the optimizations on software and use your AI and ML models for both training as well as inference. You can get more information on the instances on the link highlighted at the bottom of the slide. These numbers show you that AWS services experience faster performance due to its hardware and software-based optimizations on Intel-powered instances for AI. Whether it is the DLAMI for CPU training that sees a 7.4x performance boost, to DLAMI for CPU for inference that sees a 12x performance benefit, to the AWS SageMaker that sees a 10x performance benefit boost on ML algos on CPU. Even the applied AI AWS services like Amazon Rekognition, Amazon Forecast, and Amazon Personalize can get advantage of the Intel instance-based optimizations that drive a stronger performance and a lower TCO for the AI-based use cases. Speaking of use cases and partnering with AWS to make AI mainstream and performant, Intel has worked with global customers and partners to build a strong, tangible AI to solve business challenges today. By jointly investing in proof of concepts to conducting training programs and driving deep co-engineering motions, Intel and AWS have worked with a multiple set of customers and partners on the journey to business success and industry innovation on AI. For all you AI developers to get a flavor of what I've been talking about, we have designed the Dev Jam that is part of the AWS Online Summit. Do participate to get these instances in your hand. We also have over 16 Intel optimized software libraries and frameworks on the AWS Marketplace today. So if you just went to awsmarketplace.com and typed out Intel, that'll get you access to that information. Some great customer stories have been highlighted on the link above, and we have been fortunate to work with some really strong AI competency partners that you will recognize on the slide as well. Now, I would also like to highlight a few Asia-centric case studies and success stories that Intel and AWS have been collaborating on. The National Data Platform, built along with Fractal AI to analyze and make decisions related to COVID-19 disease progression for the government of India, is one really cool case study. The solution, based on Intel processors, delivered more than 100 dashboards using anonymized government and public datasets with hundreds and thousands of COVID-19 data points. Various ML models for disease transmission prediction, citizen mobility analytics, situational awareness of disease spread, and hospital care readiness were built to anticipate sustainable recovery scenarios in industry zone nationally. This continues to be the key pivot platform for the nation today. Another great case study is the Ministry of Education and the work that we did with them. The Intel and AWS Keeping Education Uninterrupted During COVID and Beyond use the Amazon EC2 instances featuring the second-generation Intel Xeon Scalable processors that help drive a 12% faster platform delivery towards the education. The Project Aspiration 2020, the learning platform on Intel and AWS, teaches over 1 million students across India today in the online world of COVID. The next really great case study is the University of Sydney in Australia. We partnered to save Australia's most threatened species, including koalas, the orange-bellied parrots, the Tasmanian devil, and the woolies. The researchers at the University of Sydney democratized data and drove ML models at a 16% faster performance rate on genomic sequencing on Intel and AWS platforms, as well as instances. Another great project is the University of Adelaide in Australia and the work that we did with them, which basically has supported them to analyze 3 terabytes of genomics data in a matter of hours and seconds. Through the analyses of the plant breeding and the acclimatization to study the diversity of wheat, researchers analyzed 48 wheat exomes and 11 whole barley genomes, totaling almost 3 terabytes of data in a matter of hours instead of days on the HPC and the ML platform that was built on Intel and AWS. Another success story is the work that we did with CSIRO. Australia's CSIRO research agency was able to increase by 60x the number of parallel wildfire simulations with 98% utilization of large AWS EC2 C5-based instances featuring the second generation of the Intel Xeon processors. This helped in saving the lives and mitigating bushfires in Australia. Another great project is the work that we did in collaboration with Singapore Port and Graymatics for Singapore as well as other coastal countries. Intel and AWS built a real-time monitoring system of long stretches of coastline, which was vital to public safety as well as security. This platform helped develop an automated coastal security solution based on AI and computer vision that would alert government personnel to potentially identify any public health as well as safety concerns. These are just a few of the use cases that brought business impact with the use of AI on Intel and AWS, and I wish I could tell you more about that. While I shared a few of the business cases, this is another great success story that showcases the impact of AI on society and citizens of the world. Let's hear from Ashton, the founder of Thorn.
Thorn was founded a little over 5 years ago to drive technology innovation to fight child sexual exploitation.
I brought it up to a friend of mine who said, oh, no, it's happening like here, like right here. And I was in Los Angeles at the time, and he said, within any 3 blocks from where we're standing, I was inside of a synagogue, he said, within any 3 blocks of where we're standing, you can go buy somebody. And I was floored by the notion of that.
We have leveraged multiple AWS services and products, including services that leverage Intel processors. And these have helped us move more quickly, helped us deliver solutions that are effective and scaled globally. They allow us to take massive amounts of data and turn it into action to find children faster and stop abuse around the world.
Early on, we started working with AWS in the launch and development of Spotlight. We actually were able to launch the tool within about a 4-month period and able to quickly get out a test version of the tool into the hands of the officers on the front line so that they could quickly tell us what's working and what's not.
We are using Amazon EC2 instances for our infrastructure, and what that's really allowed us to do as a nonprofit is allow for them to scale up and down whenever we need to, if we're seeing a volume or a fluctuation or we need to expand or scale with new functionality that we have in the application.
We are also able to quickly implement machine learning models without having to worry about building an entire infrastructure.
We went from 100 officers to thousands of officers within about a year's time. What we hear from those officers that use Spotlight on a regular basis is that it can decrease their investigative time by up to 65%.
AWS has been really instrumental for us, is kind of growing with us as our products mature, to move really quickly and focus on functionality, whether it's using AWS SQS for queuing or creating a scalable ETL system using AWS Lambda. But also later on, as these products mature and we take on more logic on our end and deploying directly to EC2 instances, like the C5 instance that is powered by Intel Xeon processors.
The difference that technology has made to speed up investigations has been substantial. We know over the last 2 years, there's been 21,000 human trafficking investigations in which Spotlight has been reported to assist in, more than 6,000 juveniles, so that's about 8 children a day.
AWS is a critical partner in the fight against online child sexual abuse. Partnering with AWS allows us to innovate and move quickly in these instances. It allows us to scale up, to scale down, to move globally, and also to bring on more partners very rapidly with kind of minimal incremental cost. And that, all of that combined works on behalf of these kids.
The possibilities with AI are endless. Let's also hear from our friends at AWS on our journey to workload excellence in AI.
Amazon and Intel have been collaborating on new technology for over a decade. Together, we've been able to pioneer new EC2 instance families which provide dramatically more bang for buck, more computational power at lower cost, which lets customers do more for less. The new C5 instance family, which we announced in November last year, is powered by a custom Intel Xeon scalable processor with a new microarchitecture, new hardware acceleration capabilities, and support for Intel's AVX 512 instruction set. The Intel Xeon scalable processor, combined with the innovations in networking and acceleration in the C5 instance family, bring about a major epoch in the world of high-performance computing, machine learning, and artificial intelligence. It's never been easier and more cost-effective to collect data at any scale, store it in a broad set of database and storage services, and then build custom machine and deep learning models. Today, businesses deploy more machine learning workloads on AWS than any other platform, including Aon, a large insurance and capital advisory company, who is running financial simulations using machine learning on AWS, which reduced the time to complete simulations from days to minutes. And the computational power of the Intel Xeon scalable processor lets customers use more data to create innovative new products and experiences powered by machine learning. Together with Intel, we've optimized deep learning engines with the latest version of the Intel Math kernel library and the Intel Xeon scalable processors available on the new C5 instance family to increase inference performance by over 100x. We've also worked closely with Intel to demonstrate how you can use familiar tools such as Apache Spark and BigDL to easily build distributed deep learning applications on AWS. High-performance computing allows engineers and scientists to solve complex, compute and data-intensive problems. HPC apps often require high network performance, fast storage, large amounts of memory, and very high compute capabilities, making them an ideal workload for our compute-optimized instances, including the new C5. Running these workloads on AWS gives customers instant access to thousands or tens of thousands of EC2 instances running Intel Xeon processors, allowing them to increase the speed of research in a cost-effective way that would not be practical in most on-premises HPC environments. For example, Novartis used 10,600 EC2 instances and approximately 87,000 compute cores to conduct 39 years of computational chemistry in just 9 hours, screening 10 million compounds against a cancer target. This magnitude of improvement is changing what is possible in industries such as healthcare, life sciences, financial services, scientific research, aerospace, automotive, manufacturing, and energy. We're super excited to see our collaboration with Intel continue, and for customers to continue to innovate on AWS through the best performance available anywhere.
As promised, I am very excited to introduce to you the Habana Gaudi processors. These are the new EC2 instances built specifically for machine learning training and are powered by up to 8 new Habana Gaudi processors from Intel. As announced at AWS reInvent by Andy Jassy, these will deliver 40% lower cost to train on deep learning models over existing GPU-based instances. To know more in detail, we have Eitan, Chief Business Officer at Habana Labs, take us through what Habana is all about. Over to you, Eitan.
Hi, everyone. My name is Eitan Medina, and I am the Chief Business Officer of Habana Labs, an Intel company. In this session, I will talk about the upcoming AWS EC2 instances for deep learning training based on the Habana Gaudi AI processor. Habana was founded in 2016 to deliver AI processor to the data center and cloud for training and inferencing deep learning models. While building chips is hard, building software and the ecosystem is even harder. So joining forces with Intel is helping us connect the dots. Since the acquisition of Habana Labs by Intel last year, we were able to significantly boost our R&D resources, and we are leveraging the scale that Intel can provide in number of customers and ecosystem support by partners and CSPs. At Habana, we have 2 product lines, Gaudi for training and Goya for inferencing. Both are designed around a common architecture and software stack. In this talk, we will focus on our Gaudi, the training solution, and specifically on the upcoming Gaudi-powered EC2 instances. The Gaudi-based EC2 instances are the first non-GPU training instances in AWS. In his keynote, AWS CEO said that these instances will deliver 40% better price performance to the end customers relative to the current GPU-based EC2 instances for training deep learning models. So the value proposition is lowering the cost to train for the end customers. As an example, an 8 Gaudi system delivers throughput of 12,000 images per second training ResNet 50 in TensorFlow. The EC2 instances will feature up to 8 Gaudi accelerators and will be available to customers as standard EC2 instances via an easy-to-use and pay-as-you-go usage model. Developers will be able to spin up these instances via AWS ECS and EKS for containerized applications and also via Amazon SageMaker. The Gaudi instances will support a wide range of machine learning workload, starting with natural language processing, image classification, object detection, and recommendation systems. Scaling across multiple Gaudi-based instances will be provided using the AWS Elastic Fabric adapter technology. Gaudi is designed from the ground up for doing one task well, to train deep learning models. To do that, we focus the architecture on efficiency and scalability. The compute architecture is a combination of fully programmable tensor processor core cluster and a centralized GEM engine. These tensor processor cores are essentially VLIW SIMD machines designed with custom instruction set architecture and special functions that were specifically designed for AI. The Gaudi chip integrates 32 GB of HBM2 memories, which make it easy to port models for GPU users. Finally, Gaudi is unique in integrating 10 ports of standard 100 gigabit Ethernet RoCE on chip, as opposed to proprietary scaling interfaces you see in other architectures. So overall, improving cost performance is achieved through efficiency, namely higher utilization of the compute and memory resources, and the native integration of RoCE for scaling. From day one, we focused on the software experience, as it is critical to make it easy for developers to use the innovation we have in the hardware. Most developers use TensorFlow and PyTorch for building deep learning models. So the Gaudi Synapse AI software suite comes integrated and optimized for TensorFlow and PyTorch. We expect most developers to be able to take existing models and with minor changes to the training scripts, run them on the Gaudi-based instances. Habana will provide detailed guides for developers to take advantage of. In addition, expert developers who are familiar with writing their own kernels will have access to the tools in order to create custom kernels and augment the Habana-provided kernel library. Open access to documentation, library, software, and reference model will be provided through Habana's GitHub with regular updates on the software roadmap and bidirectional communication with Habana developer community. These resources will be available concurrent with the AWS instances availability. To summarize, Gaudi brings new level of efficiency to AI training, and by lowering the cost to train, we hope to enable more customers and more applications to take advantage of the insights and end-user experiences that AI training can provide. Thank you.
Thank you, Eitan. Exciting. So, to summarize, Intel Xeon and the Habana Gaudi-powered instances on Amazon EC2 will help you harness the capabilities of AI to build faster and stronger AI for your businesses. To know more, join us. To learn more about everything that I just talked about, there are links provided above. Explore the instances mentioned in my session, as well as in the slide for recap. And last but not the least, engage with us. If you are building or deploying AI/ML related applications, feel free to reach out to me via email or LinkedIn or your AWS representative. It would be our pleasure to collaborate. I leave you with Intel's global mission statement. It is to create world-changing technology that enriches the lives of every person on Earth. We invite you to join with us on this journey together. It was my pleasure to spend this time with you, and I hope you found this session valuable. I am Akanksha Balani, the AWS APJ Alliance Head at Intel. Thank you, and have a great day.